This is a Rapatronic camera that Harold Edgerton and I developed specifically for photographing atom bomb explosions. It's called a Rapatronic camera because the shutter is a rapid action electronic shutter brought about by means of a coil of wire wrapped around a special glass cylinder, and a condenser discharges through that cylinder in the same way that you produce an electronic flash, but instead of a flash, the energy of the magnetic field opens and closes the shutter in 3/millionths of a second. Now, in order to turn this camera on and off at the proper time, we had a delay mechanism down at this end of the camera. Coming into the camera, feeding in through these couplings in here through cables, was a photocell signal, which would determine zero time. And this photocell would pick up the light coming from the X-ray of the casing of the bomb long before it exploded, and we'd call that zero time. We'd feed that signal into the camera in here, and then by means of this knob in here, we would adjust the actual delay, and we could adjust the delay from a few microseconds out to several hundred milliseconds out at this end. We can start out with a whole series of these cameras. Let's say we start at 100 millionths of a second after zero time. Then we can delay the next camera for a few millionths of a second later, and delay the next camera for maybe 100 millionths of a second later, and the next camera for maybe a millisecond later, and so on, 100 milliseconds later. The reason for taking these pictures was to measure the diameter of the expanding fireball from the explosion at different times. And this information could then be used to determine the efficiency of the explosion.